Hello, my name is Krister. This is the first lab of Opti 471B called Kinematic Design and Beam Alignment. For the first section of the lab, a laser was placed 200 millimeters above an optical rail and was aligned so that it was parallel with the rail. This was done by using a pinhole and sliding it along the rail to align the laser. When the pinhole was far away from the rail, tip tilt adjustments were made, and when the pinhole was close to the laser, translation adjustments were made. This was done iteratively until the beam passed through the pinhole at all places on the rail. Next, the levelness of the table was examined using a pentaprism that deviated the beam 90 degrees and a petri dish full of water that retroreflected the beam. This beam is shown in the picture away from the pinhole, indicating that the table was not exactly level with gravity. Next, a second rail was set up that was perpendicular to the first using a pentaprism. This was then replaced with a beam splitting cube that was then adjusted so that the beam went down the new perpendicular rail. Next, a second laser was added and aligned using the same method as the first laser, and then shone through a pentaprism that combined with the beam going through the beam splitting cube. The beams are shown to be coincident both far away and near the beam splitting cube. For the next section, a laser was used to align a Galilean telescope by aligning the retroreflections from both surfaces of both lenses. Finally, a similar method was done to align a microscope by aligning one of the large expanded spots over the crosshairs and moving the microscope along the rail to make sure that the spot stayed over the crosshairs.